All right. 4. This ties directly to what we just did. Okay, so basically it's kind of taking what we already did and tying it all together and explaining the meaning behind it. You can see where I have X-nayed one part because we are at that point of what do we need to know, what's not a nice to know. Look at this slide right here. I typed it all on here so that you would not have to write it. You already know the first 2 bullet points. You know that polynomials have at least one solution, right? There's an answer somewhere. You also know that if you have a polynomial of degree n, then that means that you have at most that many solutions, right? You already know this. So, for example, I'm going to put i.e. f of x equals, let's say, x to the 4th. That polynomial has how many possible solutions? 4. So I'm going to say has at most 4 zeros. We really need to start using the word zeros instead of solutions, I guess. But you already know that. Here's the new part for today. You've got to get comfortable with imaginary numbers and radicals. If I tell you that a plus bi is a 0, then you need to be able to say, oh, well, then its conjugate is also 0, where you change the sign of the imaginary part. If I tell you that an irrational solution is 0, then its conjugate is also 0. What do I mean by that? I.e., for example, if square root 3 is a 0, if I say that, the new part is, then negative square root 3 is 2. You change the sign of either the imaginary part or you change the sign of the radical part. Because you got to think about it. When we go back to solving quadratics, if we solve by square roots, you don't have to write this. But recall, if we had x squared minus 9 equals 0, and I said solve that, you would add the 9 to the right, then you would square root both sides, right? And what did I say you have to write on the next line every time? You have to write positive, negative. Remember that? Same concept. It's saying, hey, if I tell you that here's a radical that's a 0, then I'm secretly also saying that the opposite sign is a 0 too, and it's because it came from this. And the same thing holds true with complex numbers. If I say 4 minus I is a 0, then you would say, okay, then 4 plus I is also a 0. All right? Now let's go to the algebra. Find the polynomial function of degree 3 having the zeros 1, 3i, and negative 3i. So in the last section, I gave you the polynomial. I told you to check whether a number was a 0, right? Okay, this is the reverse. I'm saying, hey, here's the zeros. Can you tell me what possible polynomial it came from? Now, you can't nail down the exact one because it could have some leading number in the front that you don't know. But you can do what's called a generic form, okay? So let's let's take some notes under this. It says find a polynomial, which means not the only answer. It's find a answer. You with me? Multiple answers here. Find a polynomial. They're telling you that it's degree 3. So your final answer should be x cubed as your highest degree. Then they're telling you that you have the zeros 1, 3i, and negative 3i, right? Okay, I'm going to make a note right here. So we've got x equals 1, we've got x equals 3i, and we've got x equals negative 3i. All I did was write the zeros that they told me as like, okay, so x equals this, and x equals this. So if these are the zeros, yes? Y'all with me? Okay, those are the zeros. This is why it really helps to write that. Then what are the factors they came from? Okay, come right underneath it. You're just going to subtract everything to the left. So this factor would be what? X minus 1. This factor, although it's going to feel weird, would be what? X minus 3i. And then this factor would be what? Okay. So we're already getting our answer. Now we have to clean it up because no polynomial starts with an I in it. Okay, so this is just fancy college notation. This is me saying, here's my arrow to say, okay, I'm putting it all together, right? We're going to call it function f of x. Now, like I said at the very beginning, there could be some number in the very front of this that we don't know, right? So we have to account for, there could be a number here, we don't know what it is, but we're going to put a variable in place of it to show, hey, this can have any number in front. We're going to call it a sub n. That little a sub n is just a placeholder to say there could be like a 4 there, a 5, a negative 2, a 6. A leading number other than 1. So you have an a sub n there. Now we're going to put these together. We've got x minus 1. We've got x minus 3i. We've got x plus 3i. Now we do need to make a note though. What number can a sub n not be? Because if it is this number, it wipes everything out. Yeah, okay, so you got to make a note like, okay, there's a small little restriction. A sub n cannot be 0. It can be anything you want, just can't be 0. Because then that kind of null voids everything. Now, the nice part is, about this question, we're going to pretend a sub n is just the number 1. This is the answer, but we have to clean it up because this is not polynomial form. So we're going to say, if a sub n is 1, and I'm going to put ... Now I'm going to finish this problem under the impression that a sub n is 1. Which means that little a sub n part just kind of goes away, right? That's why I wanted to pretend it's 1. I need to clean this up. Do you notice right here, you notice that that is a difference of squares. They are almost identical. They have a difference in the sign in the middle. We need to multiply that together because that's going to get rid of the i's if we multiply those together. Now, here's where you want to get comfortable with your multiplication. Because there is a difference of squares here, and this happens every time. Because that's a difference of squares, it's going to multiply and the I terms will disappear. And the shortcut is you just multiply the first term by the first term and the second term by the second term. And then you clean it up with that I squared being negative 1. So I'm just going to bring this down. X times x would be x squared. negative 3i times 3i would be negative 9i squared, right? And what is negative 9i squared actually? Positive 9. So right underneath it, I'm going to say that that's actually x squared plus 9. And I think that was it. Let me look real quick. Now you can see why I wanted to do it.
So you don't have to do all the other stuff? Use it to first and first multiply.
Because it's a difference of squares. So this function f of x equals this. If it said multiplied out, you would do first, outer, inner, last to get your full polynomial. If it said just leave it in factor form, you would be done. Here's what it looks like multiplied out if you needed it. So this is the factored answer, this is the standard form answer, and you got that by just multiplying. Okay, thank you for letting me finish. We reminded you that when you have a polynomial of n degree, that means it has at most n possible solutions or zeros. The new part from yesterday was now we're going to look at imaginary and radical solutions. If you have an imaginary solution that's a 0, then its conjugate is a 0. If you have a radical solution as a 0, then its conjugate is a 0. And then I said, because, here's why. Look right here. X squared minus 9 equals 0. If I said that that's the factor and I told you to solve it, you would add 9, you'd square root it, and you'd get the square root of, you'd get the square root of 9 is positive or negative 3. Let me change it to this. Now you'll see. Alright, so what if it was this? You would subtract 9, take the square root, right? What's the square root of negative 9? 3i, and it's positive or negative, right? Okay, so this is another way to see where this is coming from. It's coming from because when you have those ugly factors that when you're solving either produce an imaginary number, this would have been better if it had been a radical, or they produce a radical. The next step is always positive or negative. You always have to write plus or minus. And that's what this is saying. This is saying, don't forget that when you're solving and you take the square root, you have to write plus or minus, and that's something we're tying in now. We did this one right here. We found just a generic polynomial that has these zeros, and then we said if we let that leading coefficient be 1, it would look like this in factored form. If you multiplied it out, it would look like this. Okay? How would you multiply this out? You would do the whole multiply it by everything after it, and then multiply it by everything after it. The first, outer, inner, last, if that's what you want to call it. But that's what you got to be able to multiply, because I'm pretty sure in math lab, they want you to enter it like this. Okay? They don't want it like this. They want it multiplied out. So you're going to have to multiply it. Let's do this one. Same exact question, but now they're tying in, what if it has certain multiplicities? So find a polynomial function of degree 5 with negative 1 is a 0 of multiplicity 3. 4 is a 0 of multiplicity 1, and the number 0 is a 0 of multiplicity 1. Don't let this confuse you. This is saying the number 0 is a solution, right? It's crossing at 0 at the origin. So when I'm doing these problems and I read through it, I always make myself a little list. I make myself a list of, okay, what are my zeros that they just gave me? And then right next to it I say, so then what are my factors from those zeros? And that way I know exactly where to start. So the first zero they said was what? They said -1. Right? So if the 0 is -1, the factor would be x minus 1, or x plus 1. You just move everything to the left to get the factor. Now, what did it also say, though, about that 0? Yep, let me highlight it. -1 has a multiplicity of 3. So how do I tweak this to show that it has a multiplicity of 3? You just put a little cube right there. Right there is where you're going to put the multiplicity, if it's a number other than 1. All right, the other 0 was 4, so that factor would be x minus 4. Multiplicity is 1, which means nothing to tweak. And then the third 0 is 0, which means x. Don't write x minus 0. Don't write x plus 0. It's just x. Which means that's going to go in the very, very, very front. It's kind of like a GCF. Right? Okay, so you have the answer, I guess you could say. This is the polynomial. You have to multiply it together because they want it in multiplied out fashion. All right. We're also not going to worry about having to rewrite the whole a sub n in the front. It could be any number, but we don't want it to be 0. We're going to go ahead and just say, let that leading coefficient be 1. Let a sub n be 1. And now let's put it all together. So our polynomial is, you can write these in the exact order that you just listed it, but it would make more sense to pull that x to the very front. So I'm going to put it in the front. And I'm actually then going to put the x minus 4 next, and you might see where I'm going with this. And I'm going to leave the one with the cubed at the very end. Okay? But that's just me because I'm fixing to have to multiply it all out. It does not matter how you arrange this. What does matter is how you start multiplying it. And what I mean by that is you don't want to start multiplying it and then mess up with your multiplication because obviously then you'll get the wrong answer. So you want to think smarter, not harder, about how you multiply. Like I'm gonna multiply that single term into that nice little double term binomial here that has no exponent because I can do that. I cannot multiply the x in here because it's attached to a cube. So that's what I mean by be careful when you start multiplying. So at this point, that's the answer. Now it's a matter of, do you know how to multiply a bunch of binomials and polynomials? So why don't you try it first? You try. Now you might wonder, how are you going to do the cubes? I would break that apart into an x plus 1 squared and figure that one out, and then leaving the x plus 1. Let me show you what I mean. So right here, I'm going to multiply this x into this binomial, and I get x squared minus 4x, right? Okay, and I'm going to now take this, and I'm going to rewrite that, because I cannot evaluate it as a cube. I'm going to rewrite it as one of them pulled out, and then one of them raised to the second power. That's properties of exponents. So what does it mean when something's cubed? It means this crab times itself how many times? 3 times, right? So that's why don't you dare say that this is x cubed plus 1 as your final. It's not. There's a whole middle term in there that you're missing if you do that. So what I'm doing is I'm saying, okay, I'm just going to pull one of them out because now I can multiply these two together, right? That's a binomial times binomial. And then I can come over here and I can deal with this one itself. And then at the very end, I can then multiply my last stuff together. So take that off. All right. So this has to be multiplied together. It's going to give me 4 terms. You're going to do first, outer, inner, last, or you're going to distribute, however you want to say it. So x squared multiplied into x plus 1 would yield what? X cubed plus x squared. Okay. Then go to the second term. Negative 4x multiplied into x plus 1 would give me negative 4x squared minus 4x. There you go. And yeah, I do have terms in the middle I can combine. I just haven't done it yet. So now these two are done. Right? Now I need to know that. You could come over here and do it if you wanted to. And then plug it back in. That's what I tend to do when it starts to get messy like this. It's up to you. Okay, so multiplied in x into that whole thing would be x squared plus x. And then 1 into that whole thing would be x plus 1. Right? So cleaned up, that middle term would be x squared plus 2x plus 1. Y'all see how I got that? This was just me doing a little, this was me saying, hey, I'm going to come over here and work on this. And then now, before you multiply a trinomial times a trinomial, you do have to clean this middle piece up. Right here. You don't want to multiply this yet because you've got terms in there that can be combined. So this is x cubed minus 3x squared. Right? Why do I didn't mean right for a minute. Now let's see if you can multiply a trinomial times a trinomial and hang with it. You will get, without cleaning anything up in your head, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9 terms when you multiply it out. So you try it. How do you do it? Focus your attention in the first set of parentheses on just one term and visualize multiplying it through the entire second set of parentheses and write what you get. Then repeat, but with the second term through the whole set of parentheses, and then repeat with the last term through the whole set. So I really want to see if you can get it before I put the answer on the board. So you try it. Your highest degree should be x to the 5th. And I'm going to go ahead and look at the homework and see how many of these are on there. So y'all y'all can panic accordingly. I think there's 4. Hold on, let me double check. I'm looking at the homework and I see 4. 4 problems. Actually, well, yeah. No, I'm trying to. Okay, correction. I stand corrected. There are no homework problems that are a trinomial times a trinomial. They all end up being binomials times trinomials. And there's 4 of them that you have to clean up. So no trinomial times a trinomial. Let's see if you multiplied it and got it right. All right, so the way I'm going to write it is the concept that I was saying where I multiply that first term times everything, then the second term times everything, then the third term times everything. So, all right. So you got x to the 5th plus 2x to the 4th plus x cubed. So far, so good. Minus 3x to the 4th. Y'all stop me if I mess up because I'm doing it with my eyes. Minus 6x cubed. Minus 3x squared. Minus 4x cubed. Minus 8x squared. Minus 4x. Yeah. So when you clean all that up, you should come to x to the 5th minus x to the 4th minus 9x cubed minus 11x squared minus 4x. There you go. And that is a polynomial that if I was to sit down and solve it all the way, I would come to, tie it all together, I'd come to -1, repeated 3 times, and then 4, and then 0. What? That polynomial, if I was to solve it all the way down, I would come to these answers. So the math here is if I tell you, hey, here's a 0 with a multiplicity, you need to be able to say, oh, well, then here's its factor with the same multiplicity. Then you need to be able to put it in a polynomial together and then know how to multiply it. The multiplying is just straight labor, right? It's just straight busy work, I guess you could say. But they want the polynomial multiplied out. They don't want you, this was the answer, but it's not the correct form. They want it like this, okay? So if you were doing, I'm going to say this with caution. There should be like a marquee flashing with caution lights. If you were doing this in the homework and you were worried that you're going to get it wrong, because I will agree that that's a lot of work. You need to know how to do it, right? You absolutely need to know how to do it because you're going to need to know how to do it on the test. However, there is a polynomial calculator out there that you can type that in and confirm that it's this to make sure that you had it right before beating yourself up in math lab and it's saying it's wrong, okay? So I say that with a caution, because I don't want you to rely on the polynomial calculator, and I don't want to create laziness in you, and I also don't want to create, oh, I really don't have to know how to multiply it, I can just use the polynomial calculator. No, you need to know how to multiply it. Use it as a checkpoint, safety net, right? It's like the answers in the back of a book. They're not there to help you cheat. They're there to help you feel confident as you're answering along the way, right? That's what I mean by use that with caution. All right, go to the next slide. So this slide's saying, look at this particular quadratic right here. If I was to solve this quadratic, I would come down to these two imaginary solutions, 1 plus I, 1 minus I. This is what we've already talked about, that when you've got a quadratic or a polynomial, sometimes it may not be crossing the x-axis if it's quadratic. And in that case, if you go back to, like, it could be above it, opening up, right? So that means it's not crossing the x-axis, which means there's no real solution. There's imaginary solutions. However, if you look at it, all of the numbers were real, right? It says with real coefficients. But when you go to solve it, because it's opening up and it's up above the x-axis, there's no real solutions. So the idea here is that real coefficients in a polynomial can produce non-real zeros, which you already know this. Just because it's real coefficients doesn't dictate that it's a real solution. It can produce non-real zeros, and they are always of the form a plus or minus bi. Non-real means imaginary. Non-real means imaginary. This right here is letting you know that if you've got rational numbers for coefficients, it can produce irrational zeros. Just like the imaginary conjugates are a plus or minus bi, the rational conjugates, irrational, a plus or minus, I think it's c, yeah, c square root b, which means radical. We've got radical zeros. This is what we've already talked about, okay? So don't let this slide intimidate you. At the very beginning, we said, hey, if I tell you that there's a zero that's like 1 minus I, then you would have to be able to say, oh, well then 1 plus I is also a 0. Or if I said there's a 0, negative 3 plus 5 square root 2, you would have to say, okay, well then negative 3 minus 5 square root 2 is also a 0. You just have to remember, if there's an I or a radical, there's two answers. And you change the sign of the I and the radical to get the second answer, okay? Which goes to this question right here. Make sure you're reading the question to know when you actually have to multiply or when they just want an answer. Like, tell me the other zeros. Look at example 3. Suppose a polynomial function of degree 6 with rational coefficients has these as its zeros. It says find the other zeros. This means don't multiply. Don't you dare start trying to shove it all together and multiply it out. This just means tell me the other zeros, okay? Now let's make a note. Since it has degree 6, what does that mean? There's up to 6 roots. There are up to 6 zeros. I use the word roots. I don't know why I used roots, because they don't, so I'll just use the word zeros. Okay, so we've got to find up to 6, which means you got to find 6, because you're not in a position to say, oh, there's only 5 here. If it's degree 6, you're finding 6 zeros. If it's degree 4, you're finding 4 zeros. Now, they gave you some to start with, so y'all know me. Okay, so you know me, I like to make a list of what they told me, and then I make a list of, so if this is what they told me, then this is what I should be able to infer. My list is going to be called given, because this is what they're saying, hey, here's what you start with. So they gave me what to start with. -2 plus 5i, what else? -2i, and 1 minus square root 3. They've already given you how many answers? 3 of them. How many do we need to find? 6. Now my second list is where I say, okay, my other zeros that I know have to exist come directly from the ones they gave me. You're just changing the sign of the imaginary part or the radical part, okay? That's the only one that gets a sign change. So if -2 plus 5i is a 0, then what else is a 0? -2 minus 5i. If -2i is a 0, then what else is a 0? 2i. If 1 minus square root 3 is a 0, then what else is? Don't, wait, did you say -1? Only change the sign of the radical. So it'd be +1, right? No, just change the sign of the I part and the square root part. That's it. The other part stays the same. Now, how many zeros do I have now? Oh, I'm done. Because it's the complex conjugate is only change the sign of the radical part. It goes back to if you were solving it and you take the square root of both sides. There is a black Jetta with Hamilton County tags in the car parking lot when the lights on. No. Okay. It's a black Jetta, Hamilton County tag. If you know someone who drives a black Jetta and lives in Chattanooga. Their lights are on. Their battery's going to be dead. You only change the sign of the square root part. Because when you go back to when you're solving, when you take the square root of both sides, that plus or minus comes after you square root. So it's just the square root part that has a sign change. That's it. That's all. I love these questions because that's it. It doesn't ask me to multiply. It doesn't ask me to, find the polynomial. It's just saying, tell me what the other zeros would be. So that's it. Now the next one actually says, find the polynomial, which means they're wanting you to multiply. So this goes back to that one we were doing earlier where you're starting it out, you're setting it up, and then you have to strategically multiply it to the very end, and that's your answer. Okay? So you actually already know how to do this, but they are going to be some ugly, uncomfortable zeros, so let's go through it together. So find a polynomial function of lowest degree, that just means bare minimum, with rational coefficients that has negative square root 3 and 1 plus I as two of its zeros. So they're really not saying, it has to be a certain degree. They're saying bare minimum, if you know that these are two zeros, then what can you infer and then tell me what the polynomial would be? So let me move this up. Alright, so y'all know me, I make my little list over here. I like to say, okay, well here's what I'm given, and then here's my other zeros. So I was given negative square root 3 and 1 plus I, right? Yeah? You staying with me? This is difficult. Okay. If I was given negative square root 3, then what's my other zero? Positive square root 3. Okay, and if I was given 1 plus I, my other zero would be 1 minus I. Okay, so we've got 4 zeros to work with, right? Now, before we go to our polynomial, if you think back to that question 2 slides ago, we're going to just let that leading coefficient be 1 for simplicity. We want to be able to put all this together in factored form, and then we got to start multiplying, right? Okay, so I need to know my factors. This is not as simple as before where it was like, oh, if it's 3, then it's x minus 3. If it's 4, it's x minus 4. We've got to somehow produce factors out of these. So take your, you can either come down here or you can do it in your head. If this is x equals negative square root 3, subtract it over, it would come from what factor? X plus square root 3, right? And then if this said, so if you need to, I'll draw on here. I don't want this to be part of that list. So this would be x plus square root 3. So what would that one produce? That would come from x minus square root 3, right? Y'all with me? Now this one feels really weird. Just set it equal. So if x is 1 plus I, right? I'll subtract it all over. Then it would come from x minus 1 minus I. See that? You just subtracted everything over. And if this x, 1 minus I, what would it come from? X minus 1 plus I, right? Do y'all see how I got those? Did you say no? Okay. So these were my zeros. These are my factors. The easiest way to get it is to, so your zeros, those are your solutions, right? Okay, so you write x equals that number. And then to get the factor, you're just subtracting everything on the right, you're subtracting it or adding it, whatever that, you're moving it.
How did you get the 1, like x minus 1?
Because because that was the 0, right? So I just said, okay, so that's a 0. Now, subtract all that crap over. So subtract 1, subtract it, you see what I mean? And then here you would subtract 1, add I, so you should notice that the only difference is going to be the sign in front of, once again, the I part or the radical part. That's by design. Because what's fixing to happen when we multiply this together, what's going to happen is the radicals are going to disappear and the i's are going to disappear. So now it's, can you hang with multiplying this stuff together? So we're going to put it all in. We got x plus square root 3 times x minus square root 3 times x minus 1 minus I times x minus 1 plus I. Okay, so that's the answer, but we have to multiply it out, clean it up. We also want to be strategic when we multiply it out. Red means not ideal here. It's not necessarily wrong, it's just not helpful. You don't want to multiply those two together. They have nothing, like there's no pattern, there's nothing, you'd be mixing a radical with an I. It would be, y'all ever heard of a cluster crap? Cluster mess? It would be a mess, right? Okay. Green means ideal. You want to strategically multiply the stuff that has like a pattern to it because things will disappear. The radicals will disappear, the i's will disappear, right? That's the goal. Your final answer should be nice, pretty x to some power terms. We should have no square roots, no i's. Okay, so we're going to multiply these two together. Do you notice it's a difference of squares? Think back to that one that I said, let me finish this before y'all go to second block. It's always a difference of squares, and that was because that's the conjugate rule. The conjugate rule produces two factors that have one small difference, and it's always the sign in front of the ugly part. So it's a difference of squares. The shortcut for multiplying a difference of squares, now this only works with a difference of squares, by the way. The shortcut in multiplying a difference of squares is the middle term is going to cancel out. So you can just do first times first, last times last, and then you have your polynomial. And that's every time with a difference of squares. So I hate saying shortcuts because some people run with them on every problem. The difference of squares shortcut only works like right here when it is an actual difference of squares. So I'm going to multiply first times first, and then last part times last part, or second part times second part. So square root 3 times negative square root 3 would be negative square root 9. You can see where this is going, but because this is so messy, I don't want to clean it up in my head. I'm going to leave it right there. I'll clean it up on the next line. So what's the square root of 9? 3. I'll clean it up on the next line. Y'all see how we got that? Okay, now look over here. You might be thinking, oh Lord. Look at those two entire trinomials. I highlighted the first two pieces in each. Do you notice the first two pieces match, right? So instead of reading it as x minus 1 minus I times x minus 1 plus I, don't read it like that because that's confusing. That's three terms, right? Don't read it that way. Look at it like this. Yellow minus I times yellow plus I. You with me? Do you see it's a difference of squares? Come back over here. It'd be like me saying x plus root 3 times x minus root 3. I said the same exact thing with one sign change. Yellow minus I times yellow plus I. This is actually still a difference of squares if you can look at it strategically as those first two terms as like a block, right? Now, if you don't see that, then just multiply x through the whole thing, multiply -1 through the whole thing, multiply -I through the whole thing. There is nothing wrong with doing that. You will still come to the right answer, okay? And if you think that there's a chance you're not going to see the difference of squares shortcut, then go that route right now. But if you think there's a chance you're going to see the shortcut, then let me indulge you and show you how to get there. What was the shortcut? First times first, last times last. That was it, right? Now, you need to think of the first as that yellow block. So it would be that yellow block, which was x minus 1, but it would be times itself, correct? So this is where it's going to feel awkward. So it would be that yellow block times itself. So I don't want to know what that is right now. I just put a square there. I'll deal with it in a minute. I want to get rid of these i's. And then last times last. Negative I times I is what? Negative I squared. Now I can go through and clean some stuff up. What's the square root of 9? 3. So this is actually x squared minus 3. Now, right here, you can clean this up if you want, or you could just say, okay, I'll deal with that in a second, or you can come over here and do it. It's up to you. I'm going to go ahead and multiply it out. You could come over here and do like an aside. You could say, I need to know what x minus 1 squared is. So that'd be first outer inner last. Right? So I'm going to put that right here. X squared minus 2x plus 1. What is this? That's minus I squared, which would become plus 1. I'm going to put it in green. See, radicals are gone, i's are gone. I would probably say most of you did not like the little difference of squares shortcut. It probably made you feel more lost. So going back up here, I feel like everyone was fine here. Yeah? Okay, so going back here, then just multiply x through the whole thing, write what you get, -1 through the whole thing, -I through the whole thing. You will still get here. You will still come down to it, okay? Now I need to clean that up at the end. So that's x squared minus 3, x squared minus 2x plus 2. Now you have a binomial times a trinomial, which are 4 of these in the homework, so you try it. Multiply it out. Your final answer, you multiply it out, make sure you can do it. Yeah. Well, I tried. We'll see. Oh, I think it is. Do you have 2x squared minus 3x squared? Yeah. Okay. I have 2x squared minus 3x squared, but I wrote positive. All right. Besides multiplying it out, you understand? I mean, I know that's tedious. Do you understand it? I know the multiplying it out is just annoying. Okay. Here's my favorite part. These questions, we got 2 slides left because the rest of the notes we are X-naying. These 2 slides, this is my favorite type of application with this. This is where I feel like it's one of those questions where it makes you feel so smart, and if someone watches you solve the whole problem, they're going to be blown away that you can do what you're about to do with this. And it's all simple synthetic division, writing your factors, and then multiplying it out. These are the types of problems that can sometimes take a whole page. Now, our 2 examples will not take a whole page. They do take the whole box, but they don't take an entire page of notes. Okay. And this is in the homework, so you need to make sure you know how to do it. Here is polynomial. Let's look at what it asks for. Find the rational zeros, then the other zeros, and then they even say which means solve it. That is, solve it. This means, hey, what I just said meant just solve it. And then they want you to write it in factored form as linear factors. So we have a polynomial 3x to the 4th minus 11x cubed plus 10x minus 4, right? It says solve it. Normally you'd go to your graphing calculator, you'd type it in, you'd see where it's crossing the x-axis, and then there's your real zeros. But the calculator will not tell you any imaginary zeros or radical zeros in radical form. They're going to spit it out as decimals. So this particular polynomial has how many possible zeros? Up to 4. And the question is saying, from the very beginning right here, it's saying solve it, then just tell me what it is in factored form. When it says factor it into linear factors, that means they want you to show it in factored form, where your highest exponent is 1. That's what it means by linear. I'm stalling. Think back to the previous questions, where I would say, hey, check and see if 2 is a 0. What would you do with it? You plug it in and you check to see if you get what number? The number 0. Or if I said, check and see if x plus 3 is a factor, then you would do the long division, and if you come to a remainder of 0, it meant it's a factor, right? We have nowhere to start. right? They just said, hey, here's a polynomial, solve it. They're not telling me anything to start with, right? Enter the rational, I call it the rational root theorem, not the zeros theorem. It's called the rational root theorem. Do y'all remember that day I said there's 4 words to describe zeros? It's solutions, x-intercepts, zeros, roots, right? The rational root theorem is this beautiful thing that says if you have a polynomial, there is a pattern in its final answers based on its leading term coefficient and its last constant. There's a pattern that exists. The pattern is the rational root theorem will create a list of possible zeros. Possible, meaning some of them don't work. It's just, here's a list of possible zeros, and any of them that actually are answers will be in the list. Okay? So instead of sitting here starting out of thin air with nothing, we can create a list of numbers to start with, and then we go back to that hole, just plug it in until you find the number 0, and then run with that number. Okay? So let's take some notes. This up here, the rational root theorem, when you have your polynomial in standard form, which means in decreasing order, I want you to put a Q right there above that little A sub n, and then I want you to put a P right here at the end. Then I want you to come right here to the polynomial we're solving, and I want you to repeat. You get your list of rational root zeros from creating fractions with the numbers in the positions of P and Q. Now, the only part is you've got to remember that it's backwards as to how you would say the alphabet. You know, P comes before Q, but when you list it, this is Q and this is P. Every time. Okay? So it's mind your P's and Q's. This is the rational root theorem, but you need to list, you label your Q as the first one, P is the last one. Okay, we're going to create a list of all the factors of P and Q. All the factors. This is where you really got to get comfortable with your numbers. So what is P? P is 4. Don't worry about the sign. P is 4. Right? What is every number that will divide into 4? When you're creating this list, just count. What's the first number that will divide into 4? 1. Now, what else will divide into 4? Not just 1, but also negative 1, right? So when I write this plus or minus 1, it's because 1 goes into 4, but also negative 1 goes into 4. Okay? What's the next number that goes into 4? Just count. 2. But you need to put plus or minus. What's the next number that goes into 4? 4. And then, of course, when you hit the number, you're done. Right? Now we're going to repeat with Q. Q is the number what? 3. All right? Factors of 3. Counting. You got plus or minus 1. Then you got plus or minus 3. That's it. So the first part is you label your P and your Q backwards. Then you list the numbers that will divide into P and Q. Now here's where you create your fractions. You got to get comfortable with fractions, okay? We're from this right here. We are going to create a list of P over Q. Right? This is where it really helps to take your non-writing hand and point to your list as you're doing this. So I'm fixing to arrange every P over every Q and clean it up. That's where I'm coming with this. All right, so I always do this. I hold my non-writing hand over the first P, and I keep it there, and in my mind, I write it over all the Q's. So 1 over 1, what's that? 1. 1 over 3, I don't care what it is, I'm just writing it. Done. Done with that one, right? Then I move my non-writing hand to the next P, and I repeat. 2 over 1 is what? 2. 2 over 3, I'm just writing it. Done with that one. Then I go to the next one. Repeat. 4 over 1 is 4. 4 over 3, just write it. Now, let me explain to you what you just did. You just took a polynomial that you knew nothing about, except that it's going to have up to 4 zeros. Using the rational root theorem, you looked at the factors of P, the factors of Q, and you just created a list of numbers. Granted, there's going to be fractions in that list. That's what's called the rational root theorem. Rational means fraction. You can also have pretty numbers too. You just created a list of all the possible zeros. I can't stress that word enough. It's possible. It doesn't mean these are the answers. It means when I get done with the problem, the answers are in there. Okay? So instead of sitting here starting from square one and having no clue what number to pick, you're going to pick from this list and plug it in until you hit what? 0. So you go to your calculator, and I always pick the nice numbers first. I don't go to the fractions first. So I always start with 1, then I go to 2, then I go to 4, because I can just type over it, right? Then I go to -1, and then I can type over it -2, -4, until you hit a 0. So you're plugging it in. So go to your calculator. Watch your parentheses. Of course, if you're plugging 1 in, it's not that bad, but. All right, we're going to type that whole polynomial. Okay, I plugged 1 in and I got -2. What does that mean? That means 1 does not work, which means go to another number. And here's why I like to check all the positives first, because now I can just hit, here's a shortcut on your calculator, hit second, enter, it'll repeat what you just had typed in, and then it'll allow you to edit. So then you can just go over it. I got -24. What does that mean? It means 2 doesn't work, go to 4. You should see that 4 does not work. So now what do I start checking? The negative nice numbers, right? So now I'm going to check -1. Wait, how did you just put this? Second, insert. It'll let you create a gap. So I typed the 4 over it with a negative, and now where I want to squeeze a 1 in, I can hit second INS, and it'll say, okay, you can squeeze. So you should get that -1 works, right? here's where this problem is so big. You have to keep in mind, what was the overall question and goal? The whole question was solve it, and then tell me what it looks like in factored form. So what I like to do is over here, I like to say to myself, okay, I'm going to create my list of solutions so I don't forget as I'm working through the problem. We just found one. What was it? -1. All right, so let's make a note. Don't write big. So f of -1 gave me 0, right? That's what we were checking, which means we're going to run with it. You're going to do synthetic division with that -1 to break that polynomial down from a 4 degree to a 3 degree, because we're trying to solve it, right? We don't have to. Not yet. It's coming. Okay, so we're going to run with -1. So here we go. Set up your synthetic division. Refresh yourself on synthetic division. Now, because that -1 was a plain old number, you know, we're not changing the sign of it. It didn't come from a factor. So don't change the sign. Copy your coefficients. Watch out. Watch out. There's a gap on squared. Watch out. There's a gap right there on squared. All right, so we're going to bring this down. I'm going to multiply, add straight down, multiply. Now, here's the nice thing. You just found -1 to work. So if you come to a remainder other than 0, you messed up. That's where you would catch yourself with that gap, okay? Okay, big picture, focus. The goal was solve. It started as a 4th degree polynomial, right? Okay, I just divided a solution into it. So this would actually be a, what degree? Polynomial. It would be a degree 3 polynomial, right? So you don't have to write this if you don't want to, because you're going to see that we're fixing to repeat this whole process. But I am going to write right here in blue. This is actually 3x cubed minus 14x squared plus 14x minus 4. That is that polynomial, which means we're not done. The goal is get it to a quadratic, because we can solve quadratics factoring or quadratic formula. I can't solve this by grouping. I can't solve, there's no way to solve this. So we go right back to our list, okay, and you find another 0 that works. And I'm going to go ahead and tell you it's 2/3. It's 2/3 that works. So you don't have to,
So that's going to be 7.
So you would go back to the list. You would say, okay, I've got it to a cubic. I need some more answers. I'd go back up here. I already checked all the positive clean numbers, pretty numbers. I already checked -1, it worked. You can check -2 and -4, but they're not going to work. But if you check 2/3, it works. So I'm going to come right here and show that if I plug 2/3 in, I get 0. So now we're going to run with 2/3.
When can we not use grouping?
Huh?
When can we use grouping?
You won't be able to use grouping. idea is that they want you to use the rational root theorem.
Do we use the 3x cubed? I wonder.
You're going to use, so good question. So this is going to feed directly from the last line. So you don't go back to the original polynomial and divide this into it, because remember, the idea was to get it down to a quadratic. Well, right now it's a cubic. So you just pull those same numbers, down. We're checking 2/3. We've got 3, -14, 14, and -4. Now, I know you don't like the 2/3, so let me remind you that when you are multiplying by 2/3, that is the same thing as saying times 2 divide 3. So you could do this in your head if you break it down like that. Times 2 divide 3. So here we go. Bring 3 down. 3 times 2. Divide 3. 6 divided by 3. 2. Write it. Add straight down. -12. Repeat. -12 times 2. -24. Divide 3. -8. Add straight down. Repeat. 6 times 2. 12. Divide by 3. And once again, if you don't get a remainder of 0, you know something's wrong, because you should. Now, I know the bell's going to catch me, but I'm going to finish this problem. I was noticed the bell was going. This was a 4th degree. We did 1 0, brought it to a 3rd degree. We did another 0, brought it to a 2nd degree, which is a quadratic, which means now we're in familiar territory. So this is 3x squared minus 12x plus 6, right? Now, as I was telling y'all 2/3 worked, I forgot to come over here and write it. It should be in my list, right? So I'm going to come over here and make my little note. 2/3 is the solution. No. Okay. So remember, the goal was solve it. I'm going to pull, because I have no room, I'm going to pull that right here. Set it equal to 0, and now you're going to solve. You already know how to solve this. A times C, factor it. It'll factor. Oh, wait, does it factor? No, it does not factor. This one ends up being quadratic formula, I think. No, you can divide the 3 out. It actually would be helpful if you notice that every single one of these is divisible. If you don't divide the 3 out, it's not going to give you the wrong answer. It just means your numbers will be big at the end. And then eventually divide. So if I divide every single thing by 3, I get that. Now you can see it's not going to factor. So if you need to make a note, to go from here to here, I divided by 3. There are no factors of 2 that add up to -4, right? So this is quadratic formula. Remember the technique I showed you with quadratic formula? Find the crap first, then just plug it in. Okay, so b squared minus 4ac. Watch your b, it's negative, so when you put that in parentheses, it's going to, when you go to your calculator, b squared minus 4ac is 8, I think, right? 16 minus 8. into your solution. So, the quadratic formula's purpose is to be able to solve a quadratic that won't factor, and it's of the form x equals negative b. My b is negative 4, so negative b would write what? I'll write it just so people know where it came from. So negative b plus or minus square root of that crap over 2 times a. Now we have to clean it up. That would be positive 4 plus or minus, what does the square root of 8 break into? You gotta be able to reduce your square roots. That's 2 square root 2, right? So this is 2 square root 2 over 2. And now you can see why you need to be able to reduce, because what happens? Just make sure you don't accidentally cancel the root 2, because it's protected. It does not change, ever. It's these three that have to have the same. So this is actually 2 plus or minus square root 2. Now, while we're done, we need to actually write like, okay, here's my answer, here's this answer. We are done, but you can't see where your answer is here. So, my list of solutions. I found negative 1 and 2/3 by the rational root theorem. Then I found, there's 2 answers here, right? I found 2 plus square root 2, and I found what? 2 minus square root 2. So there's my list of solutions. Now, what did part B say to do? Write it as linear factors. So the linear factors, I'm just going to come right here and write it. What factor is that? X plus 1. What factor is this? So be careful. It would be x minus 2/3, right? But have you ever seen a factor that had a fraction in it? You've never seen a factor with a fraction in it. So you have to think to yourself, if it was x minus 2/3, multiply what? Multiply by that denominator, and then the fraction's gone, and there's your factor. So it'd be 3x minus 2. Do you see that? So when I write 3x minus 2, it came from this right here. So it'd be 3x minus 2, and then these you just subtract over, and you stop there. You don't multiply it. So it'd be x minus 2 minus square root 2, and I run out of room, x minus 2 plus square root 2. And you would stop there.
Okay.
No, it's beautiful.
No.
Yeah.
How do you get this?
I didn't divide it into radical. I divided it by the coefficient.